In this video, we are going to be looking at the length of an arc together. Remember, in the last video, I told you what an arc is. So if I have a circle, I told you that an arc is just a part of the circle. So we can have this part, which is an arc. So an arc is just a part of a circle. This part here is an arc. So how do we calculate the length of this arc? That's what we want to treat in this video. Remember how I simplified how to get the formula for the area of a sector? We are going to try to simplify how to get the formula for the length of an arc. Now let's do this. Now if I've got this circle, and then I have radius, I have another radius, and I'm told to find the length of this arc. How would I do it? Now remember, there is an angle that these two lines make. Let's call the angle theta. So we have angle theta here. Remember, we said that angle on a point, sum of angle on a point is 360 degrees. It means that this angle is a fraction of the total angle. So we have theta over 360. Now look, this arc is just a fraction of the circumference. Does that make sense? The arc is just the fraction of the circumference. So what is the length of the circumference? Now remember, the circumference is this outline of the circle. How do you get the circumference of a circle? The formula for getting the circumference of a circle is 2 pi r. Do you understand? So if an arc is a fraction of a circumference, it then means to calculate the length of an arc, I should be having theta over 360 times 2 pi r. So I have times 2 pi r. Here is the formula for the length of arc. Theta over 360 times 2 pi r. Do you understand this? Now remember, because an arc is a fraction of a circumference, we use 2 pi r. And this angle here is actually a fraction of the sum of angles in a circle. So we have theta over 360 times 2 pi r. Now I hope you would not forget how to get this formula. Let's take some examples. An arc subtends an angle of 50 degrees at the center of a circle of radius 7 centimeters. Calculate the length of arc. Take pi equals to 22 over 7. Now let's solve this. Remember, the first thing you want to do is to try to remember the formula for the length of an arc. So length of an arc, equals to theta over 360. Remember the area of a circumference, 2 pi r. Now the next thing is to note what you were given. Theta is the angle. We know theta equals to 50 degrees. What else? We know the radius. Radius equals to 7 centimeters. And then we're given pi as 22 over 7. So pi equals to 22 over 7. Now all we have to do is to slot these values into the formula. So length of arc equals to theta is 50, so I have 50 over 360 times 2 times pi is 22 over 7 times radius is what? 7. Remember, I can put over 1 over 1. So I have 7 here 1, 7 here 1. I have 0 cancel 0. 2 here 1. 2 in 36 is 18. What else can go? 2 here 11. 2 in 18 is 9. So I have length of arc equals to, this is 5 times 1, 5 times 11 should give me 55. So I have 55 all over 9 times 1 times 1 times 1 will give me 9. So can I turn this to decimal? So let me solve the remaining here. Of arc equals to, so I have 9 here 1, 9 in 55 should give me 6, remainder 1, so I add points here and then I put 0 here. 9 in 10 should give me 1 remainder 1, so I should be having approximately 6.11. And remember, we are told to find length, so centimeter. The unit for length of arc is centimeter or meter or kilometer, as the case may be.